Hey YouTube, just coming to you, just checking up on this, flip it around, on this block. So, what has happened here, update, we have our hairline fractures going through each one of these. I've cleaned it up with the wire brush. So, basically what's going on with this project is I had this crack right down the center here, which means it has to be fixed. Now, I thought of different things to do it. I even went so far as to thinking JB Weld, which I've really decided against. I'm not doing JB Weld on this thing. I want to fix it up properly. And so I located a machine shop, 2 different machine shops in my local city. And I guess the specialist that does the welding and the the machining said it was beyond his ability to fix. And so I've done some research. I've done some welding in the past, and I think I could fix it. I really do. So I'm gonna give it a try. I'm gonna talk to you what that entails. Is basically what I'm gonna do here is, I know this is a wet sleeve first and foremost. Let me get to that. This is a wet sleeve, so let me grab a sleeve real quick and show you what I'm talking about here. Okay, sleeves, where? Oh, here's some of the old sleeves. We'll just use the old one. So this is the old sleeve here, which is basically like a cylinder housing. And the pistons, they're right in there. And so the combustion chamber all happens within this cylinder. And that cylinder, it slides inside this. It's called a sleeve. And so when these sleeves, they get quite a lip on them. You can see here there's a big lip. When it joins from there to there, there's a big gap, which means this is kind of worn down, which means there's blow-by happening, which means that when I was running this tractor, it would start up and run just barely, but it was gutless. The thing wouldn't hardly move anywhere. I mean, and forget about pulling something. And so it meant that there was a lot of blow-by happening. Once, as we talked in the past, there was one cylinder ring that was actually broken. But what's happening is that there's a bit of a gap between here, these sleeves, and the piston going up and down. And what happened is, when that combustion fills this chamber and it explodes, it shoves that piston down and it pedals the crankshaft. And that's where you get your power to drive something. So what's happening is, when that combustion blows up in here, boom, and thrusts that down, because there's a bit of a gap in between here and the rings and the piston, a lot of that power is being thrusted in down the sides of this, and it's not, all the power is not thrusting down the piston, because it's having blow-by. The power is being lost through the sides of it because it's not sealed up very well. So anyways, this cylinder sleeve here, they fit in here, and they're known as what is a wet sleeve. And a wet sleeve means that the chamber that it is in is where the water flows. And the water flows in here in order to keep everything cool. And right here, back down in here, I don't know if you can see in there, but that's where the water pump jets the water into this area. This is the water pump here. And it fills this area full of water, and it circulates this water in here. So, which means that the sleeve, the new sleeve that we're putting in here, has these rubber seals, and they have to fit in here very tightly in order to seal up enough to where the water, of course, doesn't flow past this area down into the engine block where the oil is, and it has to also seal up here, which keeps the water from, of course, leaking in through the head, getting into the see, this is the water jacket here. I believe this is the oil jacket here. These oil is oil from here, and these jackets, is that the oil jacket? No, excuse me, that's the oil jacket. That's the water jacket. So this oil jacket spurts up oil up through down into the engine block down below, and it shoots up oil up in through here and splatters up in here into the engine head, where all the valve train and all that other stuff is up here. That way it's constantly, oil's constantly getting thrown into everything that needs to be oiled. So it keeps the water separated from that. It keeps the water out of the cylinder sleeves themselves, and it just keeps everything tight. So the problem when we insert this, because of this hairline fracture, what problem we face here is when we put a new one in, it compromises not only the strength of the block itself, which is probably not too bad because this engine is only producing it produces under 20 horsepower, which is not very much power at all, honestly. And maybe 14 horsepower, I forget exactly what these TO20s produce, but it's not about that much. But here's the thing, is that water can leak through here. So the thing is I can get away with me being, not a super professional at what I'm doing, because I lack the experience of soldering cast iron all the time. Excuse me, not soldering, brazing. But I'm going to try my hand at it, because basically all I really need to do is basically seal up this crack from water basically getting through it. And the fact that it's on top of the head, which some of you commenters have suggested, and that is that they make sprays that you can actually spray on this before putting the head gasket on. That head gasket will go over this crack, so it'll help keep that. And then the fact that the cylinder sleeve would fit in there, and then this cylinder sleeve is going to do the job of handling the force of the of the combustion. So that's not an issue. So since this is such a low powered horsepower, and it's just in a tractor, it's not like I'm going to be driving 50 miles an hour down the road or something. This is just a little tractor you put around and do plowing and stuff around the property. And I doubt I'll be driving 20 miles away in a tractor and getting stranded or something. It's silly. So it's not that high of a priority. And seeing how I have no options besides doing it myself. The only other option is shipping it down to California, where they do this kind of work of fixing this. But the problem is I contacted someone down there in California, and they stated that it would be expensive to fix. So I'm going to fix it myself. That entails this. We're going to take. This is what the fix entails. It takes this die grinder, and what I got to do is take this die grinder that has this carbon grinder tip on it, and see if I can get in here where you can see this. And what it entails is taking this good die grinder and then just moving along this line, this hairline fracture, and creating kind of a U or V notch just a little bit down into it, and doing that from the top, brazing it shut, and then doing it from the side, and then brazing that shut, and then working your way around it, patching up and sealing up that crack with the braze. Once it's brazed, I can just take a flat file. Now, I think I can get away with just doing a flat file and just kind of going over the top of it and flatten it out, because again, this is an old tractor. I don't think I'm going to do the expenses of taking it down to a machine shop and having them resurface the whole thing. I think that's just a little bit overkill to the project. Now, if this was a main drive car or something, I would definitely take it to the machine shop. But I think I can get this done with just a flat file, just filing down that braze once it's brazed in, the weld, and flatten it out. And I'm going to do also what some of you might think is the unthinkable. I'm then going to take the die grinder and gently following this kerf and grinding it out, and very carefully, and which is going to take a lot of skill on my part. And I think we can, with the die grinder, clean that up and this up to where that sleeve will fit in, which is going to be an interesting fit, because you got to come in within thousandths of an inch, which I think because of this block engine is what it is. I think it will be forgiving. And also added with the gasket up here, the sealant that I'll put on, I think we can get away with doing that. Also, so the type of braze, I've been reading up on the type of braze with some of these cast irons. Some people use the copper, and I had a hard time trying to decide whether if I should run with the copper or run with something else that was suggested online. And that is what people suggest for these cast iron is actually nickel. So this is like some sort of silver nickel rods, and it already has the flux already coated with it. So basically I'll heat this up. Now cast iron, you can't just weld it like, you know, a welding rod, because cast iron is basically the way that the structure of the steel is, that steel has a structure in the way that it's made. You know, Damascus steel, the way that you make that is you make layer and layer, and you weld together layers, and you keep hammering them down, and you keep doing that until you have a whole layering system, and it creates kind of like the grain of a tree, and where the fibers, you know, where it gives some strength, so when you hit it, it just doesn't break. But the problem is cast iron isn't like Damascus steel where it's kind of layered like that. It's more crystallized. In other words, it's like taking wood, and instead of, you know, cutting across the grain, it's like cutting with the grain. In other words, the grain's up or crystallized, so it fractures much easier. The steel isn't as strong as like steel. The cast iron isn't as strong as steel, and because of that, when you heat it up and the stress of temperatures that you put on it can cause shrinkage and warpage, and which cause that steel or cast iron, which is weaker. It has some strength to it, but it is weaker than steel. It'll cause it to basically crack just like you would on the face grain of like wood. And so if you don't heat these things up properly, they will re-crack. And also the brass, or excuse me, copper. So the copper rods, from what I hear, is not really, although they do work, and but I got to keep in mind that I'm not a professional. This is my first attempt at this, and that copper, when you are welding it to these cast iron has a lot of carbon in it, real high carbon, and the copper isn't rated for high carbon applications. Instead, something more favorable for a high carbon is something like nickel, like this. And so that would give me a little bit of an edge of having a successful weld without it cracking again. The other thing is because it's cast iron, I have to heat up this entire block. I have to heat it up, get it up to temperature, and then take my torch. I have to heat all the area up, all around this crack, where there's an even temperature before I start brazing in this nickel rod into where the groove's going to be. And then once that is brazed in, the process we have to do then is we have to keep it warm, which means I'll probably be putting this bag of sand that we have here, and we'll be probably laying down sand on this board, probably heating up the sand first, and then putting this face down into the sand, and then covering it with sand or ash or something that's an insulator to help keep the heat into this where the brazes happened. That way the braze can, all the area around the braze and all the metals can cool down slowly. That way it doesn't create another fracture from the stresses of the temperature change within this cast iron block. So it's quite the process. It's kind of tedious, but I think we could do it. I really do. So at this time, I'm going to start grinding in the grooves, and we'll see how well we do here. So what I've done is we've stuck this block right along next to the wood stove to heat up the block. Give it a pretty good heating. I need to stock some more wood in there. Get the stove just, you know, roaring. That'll help give off that heat there. And the heat should transfer into this block. Give it a little bit of a preheat, and then I'll do it again with the torch itself. I'll go along really evenly. Just make sure I get this block nice and heated where all the metal, there won't be such a drastic, you know, temperature shift when we go to braze this in. So that way when I apply the heat here, we have to get this glowing red hot to welding temperature, and then we can get the braze in there and start filling in this gap. Once this gap is filled all the way in, I can start filing it down, and then once these are all filled in, then I can turn this block on its side and then grind right along the crack down this way, all the way down with it faced up, and then do the same down along this side, all three of them. Flip it again, and then do the other side on this end on this side, and then grind it all, smooth it all up, grind it. Depending on how well I'm able to grind it, file it down, I think I can do it by hand, but if I feel necessary, you know, I will consider taking it to the machine shop. We'll see. Thanks for tuning in, and next time we'll get working on the brazing.